The process by which ammonia is manufactured on a large scale, the answer was supposed to be the Haber process. And this is the spelling. There is no R between A and B. So the process was Haber process, nothing else. Those who failed, I hope you are making correction. Part 2 of the questions was state the conditions under which ammonia gas is produced by the process in A1 above. Maybe let me first say this. There are some of you who are not writing the questions. When I give assignment, they just write the answers and send to me. You don't even keep a copy of the questions with yourself. You are supposed to write the questions down and then answer after writing the questions. If you don't keep the questions and you just answer, how will the answers help you in the future when you are revising? So you need to do the right thing. The conditions under which ammonia is manufactured. Musasi's Kathy, can you tell us those conditions? Save time, please. When I call upon you, it is a privilege. Don't hesitate.
I'm sorry.
Okay, can you tell me the conditions for this reaction where ammonia is manufactured on a large scale? I told you there are 3 conditions. I hear the page is turning backwards. Should be knowing in the head. Come on, save time.
Yep. The conditions.
You see? You see?
Mixture heat.
That is wrong.
Sure.
You have not been revising and you have not been following.
I have been following.
Can you tell me now? And I will be getting you by surprise, each one of you. Ruth, can you tell us those conditions?
So we have high pressure.
Specify. High pressure between what and what?
200 and 400 atmospheres.
What?
200 and 400 atmospheres.
Correct. Thank you. Another one?
A catalyst.
What is the name of the catalyst? By the way, for your information, those who just wrote a catalyst, I crossed. You are not supposed to get any mark. There are very many catalysts. In chemistry, you should specify. Can you tell us the catalyst you are referring to? The catalyst that is used there.
Finely divided iron.
Very good, wonderful. And finally?
Low temperature of 400 to 500 degrees Celsius.
400 to 500 degrees centigrade. Okay, but I think it is 400 to 450. So those are the 3 conditions she has answered, and there is nothing more. High pressure, 200 to 500 atmospheres, and temperature, moderate or low temperatures between 400 to 500 degrees centigrade. But in some books, you are going to find there 400 to 450. They are all correct. Don't say, but in the book I saw this. So 400 to 450 is okay. Then pressure between 200 to 500 atmospheres is okay also. Then the equation is here. That part 3 was the equation, and it is here as you can see. And it should be balanced. Many of you did not balance it. It should be balanced. You first put 2 on ammonia to balance nitrogen. Then when you put 2, hydrogen becomes 6. So you come back to hydrogen and put 3. Just like that. Part B, the ammonia formed can be converted to nitric acid in presence of a catalyst. Jacinta, what is that catalyst? Where ammonia is converted to, because the process is catalytic oxidation of ammonia. The process is catalytic oxidation of ammonia. So what catalyst do we use to oxidize ammonia?
White hot platinum foil.
Very good, that's correct. We use platinum. And the next question was asking for the equations. Let me first take you back for some short time. Yes, here we are. Then part 2 was outline the equations that take place in the manufacture of nitric acid from ammonia. Please, I said there are only 3 equations. But what happened? Many of you wrote 4. So when you write 4, what we do, the fourth one that you write that is wrong, it cancels with the second one. So instead of getting these marks, we shall mark the first 2, because the fourth one, which is wrong, has gone with the third one. So there are only 3 equations. The first equation is this one, where ammonia reacts with oxygen and in presence of a catalyst, which is platinum, forming nitrogen monoxide. Then the nitrogen monoxide formed there is oxidized because it is unstable. It is oxidized to nitrogen dioxide, which is a brown fume. This is equation number 2. The final equation where you should end is here. The nitrogen dioxide reacts with water and oxygen to form nitric acid. So these are the 3 equations that we require that lead to the manufacture of nitric acid. Catalytic oxidation of ammonia form nitric acid. Those are the 3 equations. So I repeat, please don't write this fourth one. It is not important. When we tell you to manufacture nitric acid, what is ammonium nitrate doing there? Why do you write it? Please, always follow the question. Don't just copy everything from the notes. Follow the question. I think that point is clear. Ammonia gas was passed over 2.5 grams of lead 2 oxide. That is the same reaction we looked at. The reaction we are talking about is now this one. Only that instead of having copper 2 oxide, we are now using lead 2 oxide. So the first question is state the conditions for the reaction. I'm happy many of you were writing the conditions properly. The first condition is ammonia gas must be dry. And the second condition is you must heat. Is lead 2 oxide must be heated. So there are only 2 conditions, dry ammonia and heat. Then state what was observed. Since you have heated the oxide, you know lead 2 oxide is reddish brown when it is hot. Okay, so and the color of lead solid alone is gray. So our observation should simply be a reddish brown solid turns to gray. That is the observation for part C when ammonia gas is passed over lead 2 oxide. Identify the gaseous product. The gaseous product is nitrogen and it was collected over water. It should be collected over water because it is insoluble in water. State the property of ammonia. The property is ammonia is a reducing agent. Reduction, it is the removal of oxygen. So ammonia will remove oxygen from lead 2 oxide and it forms lead. So ammonia is a reducing agent. Then the calculation was very simple. I was happy many of you passed it. You first get the moles of lead 2 oxide since you are given the mass as 2.5. So first get the RFM of lead 2 oxide. Then since you had the mass, you get the moles of lead 2 oxide. Then after getting the moles of lead 2 oxide that reacted, you use the equation to get the moles of nitrogen by saying 3 moles of lead 2 oxide produce 1 mole of nitrogen. Then what about the other moles of lead 2 oxide that reacted? So it will be a third times those moles, like that. Then you get the volume by saying 1 mole of a gas occupies 22.4 liters, and the moles you got, you get the volume. So that was it for that assignment. If anyone with a question about the assignment I had given you, you can listen to you. Okay, so let us start from here. Ammonium salts. We said all ammonium salts are white crystalline substances and they are soluble in water and are ionic compounds. That one we already know from solubility rules, that all ammonium salts are soluble in water. The sulfates, nitrates, and chlorides dissolve in water to form acidic solutions. Why is it like that? Take a look at this equation. When ammonium chloride or ammonium sulfate or ammonium nitrate dissolves in water, it forms two solutions. One solution is basic or alkaline, forms ammonium hydroxide plus hydrochloric acid. So one OH from water forms ammonium hydroxide, and the other hydrogen that remains forms hydrochloric acid. This is a common question, by the way, so listen carefully. We usually ask, why is a solution of ammonia in water, of ammonium chloride in water, why is it? Now, this solution, overall it is acidic. So a solution of ammonium chloride in water is acidic. And I want to tell you the reason. Let's look at that equation. Let me ask Hannah Benjamin. Hannah Benjamin, can you unmute? I have questions for you. Hannah Benjamin, can you tell me whether ammonium hydroxide is a strong base or weak base? I think that one is sleepy. Can you tell us? Jasmine, can you tell us whether ammonium hydroxide is a weak base or strong base?
It's a weak base.
Very good. What about hydrochloric acid? Is it a strong acid or weak acid?
Strong. Strong.
Very good. That's correct. So when you have a mixture, when you have a solution containing ammonium hydroxide, which is a weak base, and also containing hydrochloric acid, which is a strong acid, then the overall solution is going to be acidic. Why? You know the definition of a strong acid. It is an acid that ionizes completely to form hydrogen ions. Then a weak base ionizes partially. So partially means part of it just ionizes. But a strong acid, it ionizes completely. So if ammonium hydroxide is a weak base and it ionizes partially, then overall it will contain few hydroxide ions compared to more hydrogen ions from a strong acid. So in the end of it all, the number of hydrogen ions is going to be greater than the number of hydroxide ions. Why is it like that? Because hydrochloric acid is a strong acid and it ionizes completely. But ammonium hydroxide is a weak base and ionizes partially. So the number of hydrogen ions will be greater than the number of hydroxide ions. I don't know if you are getting my point there, but that should be the basis of your argument. So the ammonium chloride dissolves in water. Now you are explaining. Suppose we ask you a question to explain why the solution of ammonium chloride in water is acidic. This is what you write for us. The ammonium chloride dissolves in water to form weak ammonium hydroxide solution. I have already said it is a weak base, and strong hydrochloric acid. The ammonium hydroxide is too weak to neutralize the effect of strong hydrochloric acid, and thus the resultant solution is acidic in nature. Another person can explain by using hydroxide ions, because from a base, the reacting part of a base is only hydroxide ions. So someone can say ammonium hydroxide is a weak base and therefore ionizes partially, forming few hydroxide ions, whereas hydrochloric acid is a strong acid which ionizes completely, forming more or a large excess of hydrogen ions. So the hydrogen ions from hydrochloric acid, since they are many, they will neutralize the hydroxide ions from ammonium chloride, and they will still remain in the solution. So that's the reason why the solution is what? Acidic. And it may be, when we say explain, I told you, you should also write the equation. All ammonium salts sublime. This one we talked about it. All ammonium salts sublime except ammonium sulfate. When we say sublime, it means they turn to gas. When we say sublime, it means they turn to what? To gas from solid. So ammonium chloride, we know it sublimes, so it forms ammonia gas and hydrogen chloride. Ammonium nitrate also sublimes, forming dinitrogen oxide plus water. Ammonium carbonate, the same, it sublimes when heated, forming carbon dioxide gas, ammonia gas plus water. But ammonium sulfate, when heated, it forms sulfuric acid plus ammonia gas. So for it does not sublime. because this sulfuric acid will absorb water. You remember sulfuric acid is hygroscopic. So it will absorb water and it will again change to sulfuric acid. It is first formed as a gas, then it absorbs water. All ammonium salts liberate ammonia gas upon heating with the alkali. Didn't I tell you that as long as there is an ammonium salt and a hydroxide, an alkali is a hydroxide, then e.g. sodium hydroxide, ammonia gas will be liberated. And this is the ionic equation leading to the formation of ammonia gas. So in our ionic equation, we have ammonium ions plus hydroxide ions. The product is ammonia gas plus water. So let us now put our attention on this. Now, the other one, catalytic oxidation, that is manufacture of nitric acid. We are now looking at laboratory preparation of nitric acid. So, laboratory preparation, when in the laboratory, I told you, you always need those two substances that react together to form what you want. So, in our laboratory, to prepare nitric acid, we use concentrated sulfuric acid. Get your pen and book and write some important notes so that you don't forget, although they are in the notes here. So in the laboratory, we use concentrated sulfuric acid and potassium nitrate. However, potassium nitrate can be substituted by sodium nitrate. Remember, from the reactivity series, potassium is just near sodium. So most of the time, what potassium can do, even sodium can do. So I'm saying that instead of potassium nitrate, we can also use sodium nitrate. But the best is potassium nitrate. So these are the substances that are reacted together to form nitric acid. Now, listen carefully. In the process, when you mix these two together and heat, you will see some brown fumes in the flask. Now, those brown fumes are due to the partial decomposition of nitric acid to nitrogen dioxide. I hope I'm communicating to you. When you heat a mixture of concentrated sulfuric acid and potassium nitrate, nitric acid is formed, but you will see some brown fumes. I'm saying those brown fumes are due to partial decomposition of nitric acid to nitrogen dioxide. I told you in chemistry, it is only one gas that forms brown fume. That gas is only nitrogen dioxide. So we may ask you, explain why brown fumes are there in the preparation of nitric acid. I'm telling you, the brown fumes are due to partial decomposition of nitrogen dioxide, of nitric acid, forming nitrogen dioxide gas. Now, nitric acid, when it is formed, since you are heating, it is formed as a gas. So that gas is passed over, that gas is cooled by or is condensed by this tap of cold water, and the gas will condense to form nitric acid in the flask, and this is our nitric acid. Now, that nitric acid is formed when it is a yellow liquid, but it is supposed to be colorless. So why is it a yellow liquid? It is a yellow liquid because it contains dissolved nitrogen dioxide. So nitric acid here is a yellow liquid because it contains dissolved nitrogen dioxide. Now, we usually ask a question, how is how are the brown fumes removed, or how is this yellow color removed? You remove the brown fumes by dissolving the nitric acid in water, by dissolving it in a calculated amount of water, such that the water reacts with the nitrogen dioxide, or the water dissolves the nitrogen dioxide. So this is the apparatus. Assemble the glass apparatus as shown in the diagram. You can see. Then put some potassium nitrate or sodium nitrate crystals in the bulb of a retort with concentrated sulfuric acid. Then heat the mixture gently and then collect nitric acid in a water-cooled reservoir. So what is important here, you have to heat. Then you need to know the substances that react together, potassium nitrate and sulfuric acid. Observation, gradually dissolve with effervescence. Now, I want to say something very important. Many people usually fail this equation. Why do they fail? Please, when potassium nitrate reacts with concentrated sulfuric acid, the product is not potassium sulfate. The product is potassium hydrogen sulfate. I want you to get this point and never to forget. Potassium nitrate and sulfuric acid, the product is potassium hydrogen sulfate, not potassium sulfate. And note, this equation does not require any balancing as long as you have written correct products. And the products are potassium hydrogen sulfate and nitric acid in gaseous state. Because why is it formed in gaseous state? Because you are heating. Actually, if the concentrated sulfuric acid, its state is supposed to be liquid. So listen to this one also. When you use the state of sulfuric acid as liquid, remember it is hygroscopic or a dehydrating agent. Then the state of potassium hydrogen sulfate should be solid, and this one nitric acid should be gas. So the states here are not correct. So here sulfuric acid is supposed to be a liquid. However, if you use sulfuric acid as aqueous, that means when it is dissolved in some water, then the states here should be aqueous, and this should also be aqueous. I repeat, when you use the state of liquid for sulfuric acid, then the products should be solid and gas for nitric acid. But when you use aqueous, then the products should be aqueous, all of them. The nitric acid distills and collects in the cooled reservoir as a yellow liquid. The yellow color I told you, we usually ask this question: why is nitric acid formed usually yellow? We are saying the yellow color is due to the presence of dissolved nitrogen dioxide, where drops of the acid can be seen running the back. The brown fumes are nitrogen dioxide formed by slight decomposition of nitric acid by heat. This is what I was telling you. We may ask you to give a reason why brown fumes are seen. The answers are here. It is due to the partial decomposition of nitric acid forming nitrogen dioxide, and the equation is here. So these two are very important. We ask why nitrogen dioxide why nitric acid appears yellow in color, and why brown fumes are there. They are all due to presence of nitrogen dioxide. Industrial preparation of nitric acid, this one we have already seen. I'm not going to take time on it. We can just go to properties. It is colorless liquid, it is corrosive, that one we know. Chemical properties. This is the first one we have been talking about. It decomposes to nitrogen dioxide, oxygen, and water. And nitrogen dioxide is usually a brown fume. Acid reactions. This one you know, it reacts with sodium hydroxide to form sodium nitrate plus water. Then it reacts with carbonates to form carbon dioxide gas, water, and a salt. It reacts with magnesium to form hydrogen gas. Remember, nitric acid only. When we are preparing hydrogen gas, we use sulfuric acid or hydrochloric acid. If we use nitric acid, then it should be reacted with magnesium. Please, if you use nitric acid, it should be reacted with magnesium. If you use nitric acid to prepare hydrogen gases. Other metals do not react with nitric acid to produce hydrogen. The thing is here. I'm saying if you use nitric acid, then it should be reacted with magnesium. Oxidation reactions of nitric acid. Please, these are very important. Nitric acid concentrated, when it is concentrated, we saw this, I think, when we were preparing, I think you remember our first lesson, when we were looking at how nitrogen monoxide is formed and how nitrogen dioxide is formed. When nitric acid is concentrated, then the product is nitrogen dioxide plus water. However, when nitric acid is moderately concentrated, the product is nitrogen monoxide plus water. I remember spending time telling you how to balance this equation. It is not simple. So you first put 8 on nitric acid. And we said this equation does not require heating. So it also reacts with carbon to form carbon dioxide plus nitrogen dioxide plus water. So stop at this. The other reactions, we shall see them in senior 5. You need this one of phosphorus, you don't need to know. But this one of sulfur, you need to know. We even looked at it when we are looking at sulfur. So nitric acid reacts with sulfur to form sulfuric acid, nitrogen dioxide plus water. And it reacts when it is concentrated. So this one is important, you should know. This one you should also know. Then plus these two that we have looked at. You must know. Okay. Uses of nitric acid, it is used in manufacture of dyes, manufacture of fertilizers like ammonium nitrate. Then it is an oxidizing agent. I want us to look at nitrates. Listen, I will only talk about the effect of heat on nitrates. The nitrates of group 1, that is potassium nitrate and sodium nitrate. Note down that potassium nitrate and sodium nitrate, when they are heated, they form nitrites. So sodium nitrate and potassium nitrate, they form sodium nitrite. This is sodium nitrite plus oxygen. Even potassium will form potassium nitrite plus oxygen. And sodium nitrite is a pale yellow solid. However, all the other divalent nitrates, divalent, I mean those nitrates whose valence is 2. When they are heated, they form oxides, nitrogen dioxide plus water. For example, lead-2 nitrate, we even looked at this when we are looking at preparation of nitrogen dioxide. It forms nitrogen dioxide plus the oxide plus water. So the difference is group 1 nitrates, for them they form nitrites and oxygen. Then the other divalent nitrates, I mean those metals with a valence of 2, their nitrates, they form oxides, corresponding oxides, nitrogen dioxide and oxygen. Then silver. Silver, for it forms silver metal, nitrogen dioxide plus oxygen. Now, test for nitrate, we shall not look at this one in O level. For you just know that when there is a nitrate, when you heat it, you will form nitrogen dioxide gas, which is a brown fume. So whenever we tell you to heat a substance and you see a brown fume, you know that that brown fume is nitrogen dioxide and a nitrate is present, full stop. That's all about nitrogen and its compounds. I will expect more questions inbox because now time is up. I wish you a good day. God bless you. But if you have a quick question, you can ask.